Hey everybody, I wanted to remind you that the STAR Algebra reference materials, I put a link to this on each lesson that we've been having, but there's also there in the resource materials. But I wanted to remind you that on this, in the linear section, see this where it says the linear equations, these are all the information they give you on linear stuff. You have the standard form equation, which is ax plus by equals c, when the x and the y are on one side. You cannot see the slope, you cannot see the y-intercept, you can't even see an x-intercept. The standard form shows you nothing other than it's the equation that goes with that line. When it is in slope-intercept form, that's the one we like because it's in y equals form, and then it's mx plus b. M is the slope, you can see the slope number, and the b is the y-intercept. You can see those numbers in the equation when they're in y equals format. The third one we talked about is point-slope form. This is when you just know some random point, but you still know the slope. So in this one, this is the y minus y on one side, the x minus x in the parentheses, and in front of the parentheses is your slope number m. Remember, that is the x number of your point, and that's the y number of your point. So those are all this on this lovely STAR reference material. In addition to that is the formula for slope of a line. So if you ever forget, you look at this sheet that you have in your hand on STAR test day, and m is equal to y minus y over x minus x. That reminds you the y's are on top, that's the up and down number, and the x's are on bottom, that's your run number. Rise over run. Okay, so there's that. Today, we're going to be talking about parallel and perpendicular. So remember my wall, there's all those posters. Remember in Unit 3, there's one of these posters back here. And over here underneath the Hoy and Buck's information for horizontal and vertical lines is parallel and perpendicular. So notice the symbol for parallel is when they have two lines that look like they're like railroad tracks. Parallel means the lines are never going to intersect. Because they have the exact same slant, that means their slopes are the same. If one of those lines has a slope of 5, the other line has a slope of 5. If this one has a slope of up 1 over 4, that one has a slope of up 1 over 4. So parallel lines have the same slope. So that's the big takeaway, because they're going to give you the slope, but they're not going to come out and tell you, hey, the slope is this. They're going to say, hey, the slope is parallel to this line. So if you know the slope of that line, then you know the slope of the line that you're looking for. So parallel lines have the same slope. Big item there. The other type of lines are perpendicular. Now perpendicular lines intersect, and the intersection is 90 degrees. That little kind of a little squared off thing that they write in the corner, that's the symbol that they write when it's at 90 degrees. And here it is over here at 90 degrees. So this little upside down T is the symbol that they use for perpendicular, and the two little railroad tracks is the symbol that they use for parallel. So they don't have to write out the word parallel. They don't have to write out the word perpendicular. There's just that little upside down T. I put the 90 degrees there to remind you that it is intersecting at exactly 90 degrees. That is a right angle. Now, perpendicular lines. This also tells you something about slope. So when they give you parallel and perpendicular, they're giving you information about the slope. There's an interesting concept between perpendicular lines. If I know the slope of one of these lines and I know that they're perpendicular, then I know the slope of the other line. Line B is in red. It's up here. See how it's going up? It's a positive slope. So down here is its slope. It's up 2 over 3, up 2 over 3. So this is the slope, M, of line B. So 2/3 is its slope. Line A is going down. It's going to have a negative slope. So its slope, over here is the slope of line A, is negative 3/2. If you look at these two numbers, perpendicular lines will be the opposite sign. If one is going up, the other one's going down. So they will always have opposite signs. But in addition to having opposite sides, you also flip them. So this is 3 over 2, this is 2 over 3. So if I know the slope of this one, and I know my line is perpendicular, then I know it's perpendicular as this slope. So again, as long as you know the slope of one, then you will know the slope of the other one, because you just take the opposite sign and flip it upside down. So perpendicular lines are going to give you information about slope, as well as parallel, and if they're parallel, they will have the same slope. So that's what we're going to be doing today on today's worksheet. So let's look at this and see what we have. Now, a little geometry lesson here on this. They labeled this wrong. They labeled it with capital D, capital A, capital C, capital B. Capital letters are used to name points, not lines. When they name lines, they use lowercase letters. So this should have been lowercase d, lowercase a, lowercase c, and lowercase b. So I changed it over here on this one. You don't have to worry about it, but in geometry, you'll learn that. So I just thought I'd point that out. What they do, though, is they label points on the line. So if this was a straight line, pretend I drew a straight line, and this is point F and this is point G, then if they want to refer to line FG, they will write it as FG and put a little line above it. And that means they're referring to the line FG, and it's the line that goes through those 2 points. So that's how they normally do it in geometry. So I didn't want some of you that know geometry to go, hey, this is not right. Now, this line here that you can see, there's this little squared thing in the corner. That means this line and this line are perpendicular to each other. They're hitting at 90 degrees. Same thing here. This line is also perpendicular to this one. They're at 90 degrees. Now notice these two lines are not intersecting at 90 degrees. That's a skinny angle and a big angle. Those are acute angles and obtuse angles, okay? These are all right angles. 90, 90, 90, 90, because altogether they add up to 360 degrees in a circle. So, little geometry there. They want us to find the slope of line A. So line A is this one right here. It is a positive slope, and I need to find 2 pretty points. So I'm going to use these 2 points over here. I go up 1 and over 1, 2, 3. So the slope, line A has a slope of positive 1/3. So I'm going to write that 1/3. Line B. Line B is this one over here. So again, I find some pretty points, and I'm looking for some that are easy for us to see. I think I'm going to use, here we go. Let's use these right here at this point. So I can go up 1, 2, 3, and over 1. So again, it's a positive slope. It's up 3 and over 1. So line B is 3 over 1, or you could just say it's a 3. Either one, they're the same. Line C, let's see which one is C. This one's C. So here's 2 points right here. Now this one's coming down, so this is a negative slope. From this point, I'm going to go down 1, 2, 3, and over 1. So down 3 over 1. So this is a negative 3 over 1, or just negative 3. All right. Line D. Line D is, where's my line D? This is this one. So it's also a positive slope going up. So we had going up, going up, going up. We had 3 positive ones and 1 negative. D, let's see, here's 2 points. I went up 1 and over 1, 2, 3. This is up 1 over 3, so 1/3. 1/3. Now, they want to know, are any of these lines parallel? Well, if you look at them, D and A appear to be parallel, don't they? They should never intersect. They're like railroad tracks. They're never going to intersect. That's what parallel means. So D and A are parallel. So I'm going to say D and A are parallel. Now, how they would write it is they would say D is parallel to A. So they would put the little parallel marks between it. That means D is parallel to A. Then they want to know which lines are perpendicular. Remember the little symbol? So this says these 2 lines are perpendicular. This is line D, and this was line C. So D and C are perpendicular. They're intersecting at a right angle. So I'm going to put D is perpendicular to C. So that's how you can write it, is D and C are perpendicular. Now there's another set, because that's one angle that's perpendicular. This is another one. All of these, again, are 90 degrees around that intersection. So this is line A, and again with line C, so A and C are perpendicular. So I'm going to say A is perpendicular to C. All right, so those are the ones that we're just picking out. Now what we want to do is kind of look at this and say, okay, forget about the top part. Let's just go see if, given this slope, we have a slope of 2/3. So my M is 2/3. I want to know what is a parallel slope to 2/3. If my lines are parallel, will they have the same slope? Remember, parallel means they're like railroad tracks. Yes, they're going to have the same slope. So if my line is 2/3, the parallel line will also be, oops, wrote that backwards, 2/3. So my parallel line will also be 2/3. Parallel line the same. Now what will be the slope of a perpendicular line? I take my line, I'm going to flip it upside down. This one's positive, so the new one's going to be negative and flipped upside down. So this is going to be negative 3 over 2. So the parallel is 2 over 3. The perpendicular will be negative 3 over 2. Opposite signs and flipped upside down. That's called the opposite reciprocal. I couldn't think of the word reciprocal, but when you flip it upside down, it's a reciprocal. So these are opposite reciprocals. Opposite sign and then reciprocal, meaning flipped upside down. So if my slope is negative 4, what is the parallel slope? Parallel lines have the exact same slope. So it's also negative 4. Now when you get ready to do the reciprocal, you might want to change this one into a fraction. So if this was a negative 4 over 1, I'm going to change it to a positive, and I'm going to flip it upside down, so now it's 1 over 4. So its perpendicular slope will be a positive 1 over 4. The original one was a negative 4. So you take it and flip it upside down and take the opposite sign. So y'all go do the next two. See what you come up with. You can put the pause right here and then check your answers. I'm going to go ahead and continue on, and y'all can check your answers when you come back. So if this is a negative 1/4, the parallel will be the same, negative 1/4. The perpendicular will be the opposite sign, so it will be a positive, and this will be 4 over 1, or just a positive 4. This one is a 2, so the parallel will also be a positive 2. If I want to do the perpendicular, I need to make it into a fraction, so this is 2 over 1. So the perpendicular will be the opposite sign, and I'm going to flip it upside down, 1 over 2. So the perpendicular is negative 1/2. The original one was 2, or 2 over 1. Opposite signs and flipped them upside down. That's your opposite reciprocal. Okay, so we're going to now look at these sets of lines. We have two sets of lines in this equation, or in this problem, and they want to know, are the given lines parallel, perpendicular, or neither? Okay, so it could be or neither. So if you're trying to decide if it's parallel, perpendicular, we're only focused on the slope. So this one has a slope of 2, this one has a slope of 2. If the slopes are the same, are they parallel or perpendicular? You are right, they are parallel if they have the same slope. Or, yes, same slope makes it parallel. So in number 2, this one has 2/5 as the slope. This one has 5/2 as the slope. Now, I agree they are reciprocals. They are upside down of each other, but are they opposite signs? They are not. So if they're not both opposite signs and reciprocal, they are not perpendicular. And they're not parallel because they're not the same. So this would be a case of neither. Okay, so that's, oops, if I can hold it and spell, there we go. So that one's neither. The third one, try 3 and 4 on your own, hit the pause button, do them, and then come check your answers. Now, this one has a slope of 3. This one has a slope of -3. I agree they are opposite signs, but did they flip them upside down? No, they did not, so this is again a neither one. And then on the fourth one, hopefully you've already done these and you paused it and you've come back and out and you're checking your answers. So this one has a slope of positive 2/3. This one is negative, so they are opposite signs. And since this was 2/3 and this is 3/2, they did flip it. So this one is a case of perpendicular lines. They are perpendicular because they are opposite signs and reciprocals, meaning flipped upside down. Okay, let's go look at the next page. So that's kind of the lesson part of this. And now we're going to go practice some stuff. So here they say, again, determine whether the pair of slopes, so they didn't give you the whole equations, they just gave you the slopes. We want to know, are the lines that they go with them are parallel, perpendicular, or neither? So if the slopes are the same, it will be parallel. If they're opposite reciprocals, they will be perpendicular. So this one is a positive 2. This one is a -1/2. If I took my 2/1 and flipped it upside down, would I have 1/2? You would, and it would be the opposite sign. So this one is perpendicular. Again, you might want to pause the video and go do these and then come back and see how you did. This would be your little double check to see if you know the material. So positive 3, -3, they are opposite signs, but did they flip them upside down? No, because this was 3/1 and this one should have been 1/3, so this is a neither. I'm going to start writing neither or N for the neithers. Number 3, it's -4 and -1/4. They did flip them upside down, but they have the same sign, so this is a neither again. So I'm just going to put N for neither. Fourth one, we have positive 4/5 and a positive 8/5. Well, the fact that they're both positive means that they're not going to be perpendicular. But what can we reduce 8/5 down? I do believe 2 can be divided into both of those. So if you have a fraction that you think is different, you might want to put it in the calculator to see if it's the same fraction or not. If I divide by 2, this reduces down to 4/5. So is 4/5 the same as 4/5? Yes. If they're the same, are they parallel? Yes, those are parallel lines. And on number 5, we have a positive 5 and we have a positive 1/5. So they are reciprocals. They did flip them upside down because this was 5/1, but are they opposite signs? No, they are not. So this is another neither one. So the neithers are tricky ones because you got to really stop and think, did both things happen? Now they're giving us pairs of lines again, and then we want to know, are they parallel, perpendicular, or neither? So both of these are in y equals format. So that makes it pretty easy because I can just see the slope. There's 1/4, and this is -4. Now, they're opposite signs. If I take 4/1 and flip it upside down, do I have 1/4? Yes, so these are perpendicular lines. Here I have a positive 2 and a -2 because the number in front of the x is the slope number since they're in y equals format. Positive 2 and -2 are opposite signs, but they are not reciprocal, so this is a neither. So go ahead and pause the video, go do the rest of these, and see how you do on it. Number 8. Did you remember that number 8, the first one, is not in y equals format, but this one is? So in order to know what the slope of this one is, you're going to have to solve it for y first. So hopefully you thought of that and you've solved it for y. I'm going to go ahead and solve it over here really quickly. So I'm going to subtract 3x on both sides. Rewrite it. Y is equal to -3x plus my 5. Is y by itself? Yes, so I am done with this. So I don't have to divide anything because there's nothing in front of the y. So my slope is a -3. So I'm going to put up here m equals -3 so I can see it. So this is -3 and this is -1/3. They are reciprocals of each other. They did get flipped, but do they have the opposite signs? No, they are both negative. So this is a neither. I'm going to put an N over here for neither. Number 9. One of them is in y equals form, but this one is not. So again, I've got to solve this one for y first. So this is 2x plus 3. Whoops, that should have been a y. That should be a y. I don't know why they didn't do that. There's a typo on that one. It should be 2x plus 3y is equal to 6. So change that one, that x in this one to a y. And then minus 2x on both sides, minus 2x on both sides. Whee, there we go. 3y is equal to negative 2x plus 6. And then we're going to come back and divide by 3, divide by 3, divide by 3. Of course, the only thing I'm interested in is this negative 2/3 in front of the x. So negative 2/3 is the slope of this one. So I'm going to write up here m equals negative 2/3. This is negative 2/3 and that one is negative 2/3. If they have the same slope, what kind of lines are they? Yes, you're right. They are parallel lines. So you can either use the symbols or you can write out the words parallel. All right, this next section. They've given you the equations, and we want to write down the slope of the equation they gave us, and then we're going to write down the slope of a parallel line and the slope of a perpendicular line. So, is this in y equals format? Yes, the slope is 3. So the slope of this line that we just had is 3. The number in front of the x when it's in y equals format is your slope number. The number on the end is your y-intercept. So what is my parallel slope? It is also 3 because they had the same slopes. If they're perpendicular, instead of being a positive 3, it's going to be negative, and it's going to be upside down, so it will be 1 over 3, because the 3 was 3 over 1. So instead of 3 over 1, it's now negative 1 over 3. So perpendicular is the opposite reciprocal. Oh, is it in y equals format? No, of course not. So what do we have to do? Yes, you're right. You're going to have to go solve those two. So I'm going to let you guys solve those for y. Find your slope, find the parallel, find the perpendicular, and then you can check those on the answer key because you know there is an answer key. So I'm going to let you guys do those. Now the last page is just some review things. So we're looking for writing the equation of the line, and they give you all these equations in y equals format. So this is pretty easy because you can see the slope, you can see the y-intercept number on the end. You can see the slope is a negative, so a lot of times you can just rule off some answers just from positive or negative slopes. Since it's going down from left to right, it is a negative slope. So which answers could we get rid of? All of these that don't have a negative slope. So C and D we're going to get rid of because they have a positive slope. And my line is not positive, it is a negative slope. And since they're both negative 3/4, I don't even need to bother counting because it is going to be down 3 over 4. The question is the y-intercept negative 3 or positive 3? Well, is it crossing the y-axis at positive 3 or negative 3? By golly, you are right. It's crossing up here at positive 3. So which one is it? It is B. You are correct. So that's what we're doing on these is some of the old stuff. This, again, we're looking for the equations. They're all in y equals format. Now, you could go up here and pick 2 points and do y minus y over x minus x and find the slope and rule off 2 of them. And then you only have 2 to put in the calculator. Or you could just put every equation in the calculator because they're all in y equals format. Because they're in y equals format, you can put them in that Inspire calculator on STAAR test day and simply go look at the table. So if you had a Inspire calculator, you're going to do Control T to find the table. Those of you at home, you're going to be using the Desmos calculator. Very soon, we're going to have the Inspire for you guys to start practicing the Inspire. But for now, you're still using the Desmos. So remember, you can type these equations in and go look at that little gear thing and find the table and look at the table. Remember, you can type in X numbers to jump to those X numbers and check it. So that's pretty straightforward to do on those. Same thing down here. We're writing the equation. They give you the slope, and they have a point that it's going through. So first of all, you can rule off any of these equations since they're in y equals format that don't have the slope. So get rid of all the ones that have a negative 3/2 because we're looking for a positive 3/2. Of the two that are left, they're in y equals format. You can put them in the calculator and go check their table to see if they go through 6, negative 5. When x is 6, it's the y negative 5. So again, you can always, if they're in y equals format, look at the picture and look at the table. Undefined slope. As soon as you see the undefined, you should be thinking Hoy or Vux. U. Is U in Hoy, H-O-Y, or is U in Vux, V-U-X? You are correct. It is in V-U-X. Oops, right, X. Which means I'm not interested in the slope other than that they gave me that. But what I am interested in is what the equation looks like. In Vux, vertical lines that look like this start with x equals a number. So x equals a number is the equation of these. So if I look over here, are any of these say x equals? Yes, there's only one. X equals negative 9. And yes, because it's going through that point, and x equals negative 9. If you were to go look at the table of this one, if you put in x equals negative 9, it is just a whole string of negative 9s all the way down the x column. Negative 9, negative 9, negative 9, negative 9. All the x's are negative 9. So there you see it right there, C. Write the equation of a line going through 2 points. Remember, you can do find the slope by doing y minus y over x minus x. But also, since all the equations are in y equals format, You could also just put each equation in and just go look at the table. When x is -4 and y is 2. When x is -5, the y should be 4. One of these equations will go through both points. They have to go through both points, not just one, but both. And then here's a lovely one. Write the equation below having y-intercept of -3 and slope of 2. They're in y equals format, so all you're doing is dropping in the slope number, dropping in the y-intercept number. So remember, the slope goes in front of the x, right? It's the coefficient of the x. It goes right in front of it. The y-intercept is the one on the end, so just go pick those out. You've got the answer key, so be sure and check your answers because we're getting close to a test this week on Friday, so I want to make sure that you guys know how to do this, so check your answers. If you have any questions, come Zoom with me in the afternoons or shoot me some emails. Bye, everybody.